Hi, Andre. So this is the M-line for assignment 1. So here's problem 1, 8 vertices, 6 triangles, and there's it running. And then if we go look at the other one, first I'm going to show it to solid. So there's it solid. And then if we change this to wire frame, we go ahead and run that. And also if we come down here, you would see the vertice loop right here, how it's done with the numverts, and then down here the indices are also created. And here you can see the numverts in the bid width. Yeah, and there's the main window on the wireframe. And then if we go look in H real quick, you can see numverts is set here, and if we set to something like 55, you can also see that run. There you go. And let's go ahead and go through the other couple problems real quick over here. So for problem number 1, since the NDC Z range is from 0 to 1, if you set the value greater than 1, the parts of the triangle whose Z values are greater than 1 aren't rendered. So if you set that to 1.1, only the top of the triangle will be cut out, and if you set that to like 10, you'll only see the bottom of the triangle. For question number 2, so the coordinates for the top left, when you change those, they change the pixel position of the top left of where the viewport is being rendered. So as you move it around, the triangle stays in the same place and just the viewport is moving. I was thinking this might be helpful if you want like multiple viewports to show on screen at once. So you could have 2 different render scenes and just have the cameras in different places based on the top left. Besides, I couldn't really think of a benefit of being able to move the camera around or the viewport. And then for number 3, the first format we are using, it's for components of each an 8-bit unsigned normalized integer. In the thing, you're using it for the buffer for the swap chain. And according to what the book said, the 3 color channels are used for displaying the color, and the alpha channel is just for special effects, and you only need the 8-bit because you don't need much more precision. And as for the unorm, that's a normalized integer, which is basically just a float stored as an integer, and it's unsigned, so it's just a value from 0 to 1.0 but stored as an integer. For the second one, it's a 1 component 16-bit unsigned integer, and it's used for storing the indexing buffers. So it has nothing to do with red, it's just a way of storing pointers. It needs to be unsigned and not signed because you don't need negative pointers. And then 16-bit is fine instead of the 32-bit alternative because we're not dealing with that many vertices in our examples. And that's all for me.